This is Precalculus Concept 9a, finding the domain of a function. We've got 4 boxes. The first box here is pulled from your book, and it talks about what to be thinking about when you're finding the domain of a function. And there's 2 things in particular here that are especially important. When we think about domain, it's going to be the set of numbers or inputs that basically make the function work. And most of the time we're going to see functions where all real numbers will work. But there are 2 particular things to watch out for, and one is inputs that cause division by 0 because you can't divide by 0, and also inputs that cause even roots of negative numbers. So when answering a question about domain, be very mindful of those 2 things. There's also a couple others that we'll talk about later on, but those are the primary, what I would call problems in the domain of a function. Alright, we're also going to introduce a new notation here. When describing sets of numbers, you actually have many options. You could write a sentence, you could do something visually like I've shown here below, or you could describe them in a mathematical way. So in this example on the left, you might look at that set of numbers and describe it with an inequality. -2 is less than or equal to x, which is less than or equal to 1. Would be a very good description of that number set shown in red. Interval notation is going to be something a little bit different, but same concept. I want to describe the numbers. This time I'm going to use an interval, and all I need to do is write the beginning of the interval, comma, the end of the interval, and then I'm going to use either brackets or parentheses to indicate whether the endpoints, -2 and 1 in this case, are included or not included. So if they're included, I'm going to use brackets, and in this case I'd have brackets on both. Alright, over here on my right I actually have 2 intervals to describe. So your inequality notation might look something like this. All values of x less than or equal to 4, or values that are of x that are greater than 0. Strictly greater than this time because I'm not including 0. So with interval notation, this time I have an unbounded interval, and so I'm going to go from -infinity, comma, -4 with a bracket, and then instead of or I'm going to use the union symbol, and then I'm going to have parentheses, 0, comma, infinity. With -infinity and positive infinity, I always use parentheses. Alright, so these 2 examples here at the bottom are interval notation, and that's a often quick way to describe a set of numbers. Alright, box 3 is an example. Let's look at 3 different functions and what their domains would be, and we'll give those answers in interval notation. So looking at f of x equals x squared plus 7, any number I could think of, fractions, positive numbers, negative numbers, zeros, all give me a function that works out, so there aren't any problem points. So I'm going to describe this as the interval from -infinity to positive infinity, which simply means all real numbers. You also see this sometimes as script r also means the same thing. Alright, example 2, I've got a fraction. One of our kind of things to watch out for are inputs or numbers that give 0 in the bottom of a fraction. So I need to make sure that the bottom of this fraction is never 0, and that means that x squared can't be 9, and that means that x cannot be plus or minus 3. If I want to give that answer in interval notation, here's what it would look like. -infinity up until -3, and then everything from -3 to positive 3, and then everything from 3 to infinity. So this would be the interval notation that describes the set of all real numbers except -3 and positive 3. Alright, our last one over here, we talked about not having the even root of a negative number. So when I see any problem with a even root, square roots for example, I want to make sure that the stuff inside is greater than or equal to 0. And that means that 3x has to be greater than or equal to -2, and x has to be greater than or equal to -2/3. Alright, my interval notation for this is going to look like a bracket, -2/3, and everything above it would be everything to the right. And those are the domains for these three functions. Every function is a little bit different, but you always have to think carefully, and again, watch out for the special cases of zeros in the bottoms of fractions and even roots of negative numbers. All right, box 4 is a you try. Take a look at this function. Think about what you learned in the lesson today, and give us the domain of the function, and let's use interval notation. Alright, this problem involves an even root. I have to make sure that the stuff inside the root radical sign is a number greater than or equal to 0. If I solve that inequality, I get numbers bigger than 3 or equal to 3. So my domain of this function is bracket 3 comma infinity parentheses. That describes the set of numbers that will make this function work.